My name is Frank McKenna, and today I'm going to show you how to use the Earthquake Engineering with Uncertainty Quantification, or the EEQ application. EEQ is an application to determine the response of a building subjected to an earthquake event. What makes EEQ unique is that it's not a deterministic application, i.e. the response values returned are not single numbers. Instead, EEQ is a UQ application. The application is going to return to you as output a quantification of the uncertainties in the output given the uncertainties in the input parameters. Now inside the tool, when I use the term input parameters, I'm really referring to random variables. So what are the random variables for trying to understand how the building responds to an earthquake event? We've got random variables associated with material properties, the building mass, damping ratio, and even the input, in particular the input ground motion. Now because this is a U application, we've actually got some different inputs we have to deal with. So in addition to defining the structure, we actually have to identify the random variables, define their distributions, define the uncertainty method we're going to use and the number of samples, and then get used to the idea of running the job remotely and getting the results later. So this is the application when it's running. This is what it looks like on your desktop. Windows users might see something different. At the bottom of our application, we have a number of push buttons to run the application, to get the results, and to exit the application. Top right, we have a button to log in. Before we can run it at DesignSafe or get the results from DesignSafe, we first have to log in to DesignSafe. We do not have to log into DesignSafe. We're just running this application locally. But to run it locally, you do need to have OpenSeas and Dakota installed on your computer. On the left side here, we have input panel selection. As we go through these and change them, we're changing the main input panel. Right now we have no results. We have to go through these individually to actually set the information. We have to set the information about the building. We have to define the event we're going to use. We have to specify what our analysis options are going to be. We have to define those random variables. And we also have to set the UQ method and the number of samples we're going to run. So let's do this for a simple building. The first thing we want to do is make sure our units are correct. And also for certain events we need to specify the latitude and longitude. This is where this latitude and longitude information is set. Once we have the general information set, then we have to go into specific things for the building's lateral system. Basically, we're going to select an application. Right now the only application we can select is OpenSeas. For the OpenSeas application, we specify the script which contains the commands to build a model, i.e. define the nodes and elements. It'll do a gravity analysis if we need and also define the mass for the building. So we're going to choose from an existing example. That example you have on your computers. It came with the application. So there's the example. Now we go to the events. Unlike the previous screen where we only had one option available to us, when we come to events we have multiple options available for creating an event. I refer you to the manual to find out just specifically what they each do. We're going to add some SimCenter events. You can add and remove as many as we want. So for each event we have to choose the event file. In the folder that came with your application, again, you do have in the event folder two motions, El Centro and Rinaldi. When you create a SimCenter event, it will automatically set the factor to be 1 and give it a name. After the event, you have to go through the analysis options. Basically, what is your solution algorithm, your integration scheme, what is your convergence test, your tolerance in the convergence test, and of course the damping ratio. So let me change this to 4% damping. You also have the option to specify analysis script. If you don't like the analysis script that's set by default, you can come in here and change that analysis script. So if you have an analysis script which just does the analysis, you would select it here. Otherwise, leave it alone. Now when we come to the UQ, you see that we now have a number of variables set. When we loaded those OpenSeas file, we parsed that file, and any variable that was set with the pset command is now automatically brought in here, and it's given a constant distribution. We need to change that constant distribution to something else. So we're going to give them all normal distributions. Let's say it's 10% standard deviation. So now I'm almost ready to run. Back in the BIM file, there is this list of C-line nodes. I didn't provide any information. This program will automatically record the maximum acceleration displacements and interstory drifts for a bunch of nodes. You have to specify what those nodes are when you use OpenSees. For this portal frame, basically there's two nodes that I'm going to specify, nodes 1 and 3. If I had a multi-story building, I might need to specify additional nodes. But right now, as I say, it's a portal frame, so I'm only going to be looking at the responses at nodes 1 and 3. With all that set, I can now run my simulation. And there are the results. For example, the interstory drift. For story 1 and 1 degree of freedom direction, we get the mean and the standard deviation. We can get the peak floor displacement at the second floor and the peak floor acceleration at the second floor in the 1 degree of freedom direction. We also can see this graphically. When the UQ engine does the forward propagation of uncertainty, it's basically running into a number of deterministic samples. And for each sample, it's basically setting what a variable for the random variable. It's setting a value to use for that simulation. And it does the simulation and calculates the response. And basically, we're seeing the mean and standard deviation of those values is what's actually presented. But we can see how they vary graphically. If you right-click on one column and left-click on another, you start changing the axis. You can see how things vary, FC versus the interstory drift. We can also run this at design safe. Before I can run it at design safe, I do have to log in. So now I'm logged into design safe. Oh, no, I'm not. It takes a little while to log in and send information across the network. So before I run it at design safe, I'm going to go back to my sampling methods. I'm going to still use Latin Hypercube, but now let me run, say, 30 simulations. Well, 32. So now I can run this at design safe. Again, when I hit run at design safe, another window pops up. This window, there's more information to be filled in. Again, you do not want to touch these bottom four. You do want to give it a job name. You do want to specify the number of nodes that this job is going to run on and how many total processes to use. I'm going to use one node, and I'm going to use 32 processes on that one node. And basically you need to specify a wall time. If you specify a wall time that's too short, your application will be killed. So pick something appropriate. So now with that set, I can now run this. So what this does now is it's basically taking my files and sending them across to Design Safe. When they're across on Design Safe, it will start the application. Once the application has been successfully started, this window will go away. So while the job is running, we can actually make sure it's running. So we're going to go get from Design Safe, and we'll see that there's our test 7. It's still in the pending status. To change the status, basically left-click on the jobs whose status you want to see, and it gives you a number of options. Refresh job will change the status. This one is still pending. So let's do stuff while this job is pending. Just to show you what, we're not stuck with random variables in the model. We can do random variables with the event. For example, let's have a factor on the ground motion. Let's change the damping ratio to be a factor as well, say. And then we go to UQ, we go back to my random variables. I got to set these values. So let's put a uniform distribution on the load factor. And the damping, why not the damping ratio as well? So let me run this simulation. Again, we don't touch that. It's taking a little bit longer because I didn't change the number of simulations I ran. I'm still running the 32. But we see the the new random variables in our table. I want to show you one other thing. Basically, when we add another event, we're going to add that Rinaldi that was in there. So when it runs successfully, again, when we come to the output, we'll see the table values. You'll see there's two distinct sets of values. One of those is Rinaldi, and the other is El Centro. So let's go back now to the summary. I just wanted to show you something here. Once we use these discrete events, we no longer get a mean and a standard deviation. We're now dealing with minimum and max values returned from the uncertainty quantification engine. So let's go back and see if design safe is done yet. When we come back now, we see that test 7 is finished. So we can now go retrieve that data for test 7. Again, it takes a little while to download the files from design safe to the computer. Processing them, as you'll see, once the files are downloaded, is pretty quick. So here are the results. Once we're done, we can always exit the application.